waters will travel towards the lower saline areas, right? So these two factors, one is the heat energy and one is the difference in density of the salinity, if I can say. Due to these two factors, the oceanic waters have the circulation pattern. And this circulation, actually, if you can say that why the current is not moving like this, why is it having like this, why is it flying like a flight, right? See, you know, an interesting part of it, like I have some friends from the South American parts, I have some friends from this US parts. There, when they travel to their home, their flight actually follows this path. Their, I got also confused that why the flight didn't follow like a straight path like this, because it would have been much more easier. But the flight actually follows a differential, like a path which connects the like coasts. One of the prime reason is that they want to be in touch with the lands, and another prime reason is that they follow the circulation pattern of the atmosphere and the ocean in that way, the airways actually. So see, the reason why this is moving in this way is because of the rotation of the earth, and the rotation causes the winds and the ocean currents to deflect to a different direction, right? So the ocean currents here, you can see that the in the northern hemisphere, if I can say, this is the equator, like this is, you can imagine this to be the equator. I'm also giving a reference. For example, take this to be the equator, if I can say. Then the northern hemisphere, in the northern hemisphere, I can say is that the oceanic circulation is clockwise in nature. You see, the normal oceanic circulation in the generalized way, the oceanic circulation in the northern hemisphere is clockwise in nature, but in the southern hemisphere, it is in the general way, it is anti-clockwise in nature. Okay, this question actually comes in net also, which is clockwise and which is anti-clockwise in nature. This type of question actually comes. So remember this thing, that the motion of the the ocean currents is clockwise in nature in the northern hemisphere, but anti-clockwise in nature in the southern hemisphere. Okay, so as we can see, the oceanic currents actually moves in this way. There happens to be a change at the this movement actually happens due to what? There is a change in the temperature and the salinity. So the oceanographers who first like classified these oceanic currents, so what they did, they gave the five major ocean currents. Okay, I will come to this five directly. So they first gave five major ocean currents. That is the one, two, three, four, five. Okay, one is the North Pacific oceanic gyre. This the major oceanic, like for example, I will also like describe what gyre is. See, there is a division between the Atlantic, the Pacific, and the Indian Ocean. Okay, to like study the ocean currents throughout the world, the major ocean currents, the oceanographers divided the whole ocean body into five sectors. One is the North Pacific sector, another one is the South Pacific sector, the North Atlantic sector, the South Atlantic sector, and the Indian Ocean sector. Okay, and these major sectors that I'm mentioning as sectors, these were known as oceanic gyres. Okay, this North Pacific gyre, the South Pacific gyre, the North Atlantic gyre, the South Atlantic gyre, and the Indian Ocean gyre. Okay, and these gyre actually means is that the circulation pattern. Matlab gyre actually comes from this word that is gyros. The gyros means circle. Okay, so the terminology, the gyre, this North Pacific gyre or North Pacific, South Pacific gyre, these are the major circulatory, as these are almost forms a circulatory pattern. That is why these are known as uh, gyres or gyres, whatever. Okay, so for like easy of travel, for easy of understanding, they named the gyres into different types. Like the North Pacific gyre is known as the turtle gyre. Okay, the South Pacific is known as the haired dial gyre. The North Atlantic is known as Columbus gyre. South Atlantic is known as navigator gyre, and the Indian Ocean is known as Majid gyre. Okay, I would suggest you guys to at least remember which gyre is which, because in some cases in the net examination, sometimes they give questions like this type of questions came in earlier times. I don't know whether they can give or not, but it's better to be prepared that they just give which of the following is a part of Columbus gyre. Okay, and they give like Gulf Stream and the other ones from other ways. Okay, and you have to like understand what is meant by the Columbus gyre, and if you know what is Columbus gyre, you can answer it. Okay, to remember, you have to, the only difficult portion of this whole oceanography for you, the other portions are all conceptual. I told you guys when the first time I am teaching the oceanography, I told you guys that most of the conceptual thing I will make you understand, but the thing that you have to remember, that I can't like force you that please remember like that, but I can only suggest you guys that yes, this is the only portion of the oceanography that you guys have to remember. Okay, so the I would suggest that it's better not to like memorize from here, but to visualize and understand through here. Okay, like if you are studying North Atlantic current, so just remember which are the currents: the Canary current, the Gulf Stream, the Greenland, these portions. You just remember which are of which part. When you are studying the North Pacific current, Kuroshio, Oyashio, California, Pacific, Pacific, okay, so now is the next classification, this red and blue lines. Why are they red and why are they blue? So what happens is that this oceanic currents, like as I mentioned, due to the difference in temperature, one of the oceanic currents gets more heated than the others, and they travel to the colder parts, right? So these oceanic currents are into two types. One is the warm ocean currents, that are the red ones, the red lines. Another one is the cold ocean currents. Okay, so the cold ocean currents and warm ocean currents have different characteristic features, right? And at the same time, the, like I can say about the first, I will say about the warm and cold currents. The warm ocean currents, they are those ones which carry warm waters. The temperature of them is a bit higher, right? And these warm ocean currents, what they do, they are responsible for rainfalls. Like when they are traveling through a certain coast, they will bring with them the moisture laden air, and that will cause rainfall in the in the area where it is flowing. Okay, like it will cause rainfall where it is flowing. Okay, all right. So as I can say that these, and the cold ocean currents, for the cold ocean currents, these I'm just summarizing the giving you the conceptual portions throughout this chapter. It's up to you. You can study, or you can just go through it, you can read it, or you can like do not you cannot read it. It's up to you. Not to do the cold ocean, the most characteristic feature, the most important feature, one is that they bring like the cold temperature, and for that reason the temperature in that area reduces. Okay. And another thing that it does is that the cold, remember, for oceanography we have to study the temperature of the ocean. Okay. So in any kind of oceanography, cold, like they are much more enriched in water minerals, water nutrients. Okay. And for that reason, cold ocean currents have much more oceanic life or oceanic bios, okay, than that of the warm ocean currents. The cold